In this video, we are going to begin the process of taking a look at the evolution of a complicated program. The idea of this program is to have the computer program paint a ball on the screen and then to keep erasing it and redrawing it in a new position as to give the impression of animation. So it'll look like the ball's actually moving across the screen. A more detailed discussion of the topics that you're seeing here are in your textbook on pages 168 through 175, if any part of this video is not explaining everything in detail for you. So we're going to start with the very first iteration of this, which I'm going to call iteration 0. And my first attempt is just going to be to draw a ball. So in order to do this, we need an applet. So we're going to be importing java.awt.star and import javax.swing. These two things are always imported for applets. You can see that this program is going to be an applet because in my class declaration, public class Ball Bounnce 0, it says extends JApplet. So remember, when you're extending off of JApplet, you get to use the features that are inside of the JApplet package. And one of those things is to be able to paint stuff to the screen. So remember, JApplet, you do not need to provide a main method for applets. The main method exists inside of JApplet. So one of the main methods that we use in applets is a method called paint. So public void, because nothing's going to be returned. Paint graphics G is the parameter that's being passed here. It allows you to actually paint within the viewing window. And what I'm going to do inside of here, this is something new we haven't seen before, g.filloval. So when we're doing a fill oval, what that means is it's going to make an oval, and the four things that you're going to need to provide are the X location and the Y location for the top left corner of the ball. So this right here would be the location of X and Y, so 100 pixels to the right and 50 pixels down from the top. The next two things that you see here, the 30 and the 30, represent my width and my height for the oval that I'm drawing. Now, since my width and height are both the same numbers, 30 and 30, it's actually going to come out to be a circle. So even though it says g.filloval, if you make the width and the height the same, it's actually going to be a circle. So this is my very first attempt at this. And all this is doing right now is just drawing this picture right here. So if you were to write this code and compile it and run it, this is the picture you would get. It would just paint a ball 100 pixels, 100 pixels to the right and 50 pixels down from the top left corner of the screen. And it would be 30 pixels wide and 30 pixels tall. So in my second iteration of this code, I'm going to do a couple of little changes. One of the things that I'm going to do is I'm going to change the color. So if you don't specify a color, it's going to paint black. But I'm going to change the color to red for the oval. And I'm also going to use a loop that keeps adding a little bit to both my X and Y values so that it will keep redrawing the ball in a slightly new position for each step of the loop. So here's what that's going to look like in terms of the code. Again, we're importing stuff for an applet. It's an applet because it says it extends off of JApplet. We're using the paint method. Right here is where I'm setting the color. So g.setColor, color.red, that will now tell Java to be using red whenever it does its painting. And I'm going to set up a for loop that starts at 0 and goes up to less than 200 and increments by ones. And as I do this g.filloval, instead of always painting it at starting at 100, 50 as the X and Y coordinates, you can see I'm adding I onto both my X and Y coordinate. So the first time through, since I is 0, I'm adding nothing onto these. So that first circle will be drawn at 100, 50 with a width of 30 and a height of 30. But every time I go through this loop and I becomes bigger and bigger and bigger because we keep adding 1 to I, I'm going to move the X coordinate over 1 pixel to the right and I'm going to move the y coordinate 1 pixel down. And so what's going to happen here is, because I'm not erasing anything, as it keeps drawing these circles here and then here and then here and then here, it's going to end up looking like one big red smudge going across your screen from the upper left corner towards the lower right corner. This is better, but this is not quite what we want. So in my next version, instead of incrementing the x and y values by 1, I'm going to increment the x and y values by 25s. So what that's going to do is move the ball position significantly so that they won't be overlapping on top of each other. So again, here's the code, and here's what I've changed right here. The only thing that I changed is how I'm incrementing I. Remember that this is a self-assignment operator. The plus equals means that you're taking the current value of I, you're going to add 25 onto it, and then reassign it back into I. The first time through, I'm adding nothing on, so it paints the ball in exactly the same spot that it always started, 100, comma 50. But the next time, I'm going to move over 25 and down 25 and repaint the ball. This time that the balls are not going to be overlapping. But it also means that I'm going to get to 200 a lot quicker if I go by 25s. So as you can see in this picture, there's only 8 different balls painted. When I was 0, when I was 25, 50, 75, 100, 125, 150, and 175. If you're wondering why there's not a 9th ball, like why is it not painting it when I is 200, right here you can see that I is strictly less than 200. So it won't paint it again once I is 200. In this 4th version of the code, we're going to make a few more changes to make this more like a normal class. So what we're going to do is, in this version of the code, we're going to give the oval its initial coordinates as class variables. So right here you can see we've defined variables int x and int y. I'm starting x off at 100. I'm starting y off at 150. With these being class variables, meaning defined outside of a method, that means I can use them anywhere in this class. So if I want to make changes to x or be able to use the value of x, I can use it anywhere in this class. I'm also going to give, instead of just incrementing the x and y coordinates, I'm going to give my class x velocity and y velocity. That's going to tell me how much to change the x by and how much to change the y by every time I run through one of these steps of my loop. Another thing that I'm going to be doing is I'm going to be erasing the old ball before I update the position and redraw the new ball. So the way that you erase something in Java in an applet is kind of interesting. What you want to do is you want to paint with the same color as the background. So in other words, since the background to this is white, I'm going to set my color to be white. I'm going to paint where the ball used to be with white, which will basically erase it. Then I'm going to make the changes to my x position by adding on the x velocity, make my change to the y position by adding on the y velocity. Then I'm going to set the color to red, and I'll redraw the ball in its new position after we've made the movement. Now, if I were to just do this, the program would run so fast that you wouldn't see the individual steps of the ball, because the computer can process millions and millions and millions of lines of code in a split second. So what we want to do here is we want to try to slow the program down. And the way that I'm going to slow the program down is by doing this right here. I'm going to create a for loop, have it start off at 0, and make it count up to 2 million by ones. So 1, 2, 3, 4, all the way up to 1,999,000, all the way to the end. And then eventually when it finishes counting to 2 million, it'll go back, erase the ball in its current position, change its position, and redraw the ball in red again. So it will look like the ball is moving across the screen. Where the dotted circles are, that's where the ball used to be, and then it got erased. And then it was here, and then it got erased, and then it was here, and then it got erased, and then it was here, and so on and so forth. So you would actually see what looks like movement of the ball across the screen, which is kind of cool. That's where we're trying to get to. The one last thing that I want to mention about this code before we move on to our final version of this, um, because the X and the Y are always being incremented in the same direction, eventually you're going to reach a point where this ball actually leaves your screen. And once it goes off the screen, we won't see it being drawn anymore. Even though that the code will keep updating it and try to redraw it, it won't be within our viewing window, so we won't see anything. So in our last version of this, we're going to try to put boundaries around this and make the ball stay within the viewing window. So in this final version of the program, it does what the previous program did. We have our X and Y locations as class variables. X and Y velocities are also class variables as well. That tells us how much to move every time the timer fires. We are going to do this 20,000 times. And what we're going to do is erase the ball by setting the color to white and filling in the oval in white, which makes it look the same as the background color. Then we will update the position of the ball. Now here's the new stuff. Right here, over here, and all the way down to here. I'm going to put limits on where my ball can go. If the X position of the ball is greater than 350, I'm going to negate the X velocity. So what that means is if your X velocity is positive, like it used to be +1, once I get to this point where my X value is 350 and I negate the X velocity, instead of continuing to move the ball to the right, negating the X velocity will bring the ball back towards the left. And I want to do the same thing if my X value gets to be less than 50. That means I'm starting to exit the screen off the left side of the viewing window. If I negate the X velocity again, that would, by the way, if you're exiting left, that means you're moving towards the left. That means you're subtracting your X values, your X velocity from your X values. And if you negate it again, that would turn it back around and make it go to the right. We would want to do the same thing for the top and the bottom, but this would be in the Y direction. So if your Y value gets to be greater than 250, or if your Y value gets to be less than 50, we want to negate the Y velocity. So if I'm going off the top, that means I'm subtracting Y's. Before I get to the top, I want to reverse the direction by changing the Y velocity. And if I'm going off the bottom, that means my Y values keep getting bigger and bigger. I'd want to change the Y velocity to get it to bounce back in. Again, once the update has happened and once you check to see if you're going to hit walls, we would want to set the color to red and redraw the oval. And then here is the for loop to get it to count up to 2 million, just to make the program last a little bit longer so that we can see the actual individual increments. Now, we're going to learn in next chapter that this way of slowing the program down by making it count up to a specific number using a for loop is not going to be our best plan. And we'll talk a little bit about that in our next chapter. But this program right here is going to be the introduction that's going to take us most of the way through chapter 6. And chapter 6 is a topic called event-driven programming. And this is the lead-in to that.